Okay, this is part 2 of our review of ionic bonding and covalent bonding. And we'll start with the difference between drawing ionic bonds and covalent bonds. Well, when you're drawing ionic bonds, you will definitely show an electron like this transferring over, showing arrows from one atom to another. Whereas covalent bond, you're going to be showing things like this. I'll just draw like an X. You're going to be showing electrons around atoms. And then I'll just do like a Y here where they're connected somewhere. And let's do the atom Z over here. We're not showing electrons being transferred over. We're showing that they're shared between atoms. Okay, so what really is a covalent bond? Well, we say that the electrons are shared between the two. But really, it's kind of like an overlap where electrons are attracted between atoms. And they're not actually transferred across. So there's a reasonably mutual attraction of electrons between two atoms when they're bonded. So that's what we mean by a covalent bond. So let's get right started with it. So what if I was to draw the dot diagram for the covalent molecule carbon with 4 bromines on it? So it's carbon tetrabromide. So what I'll do is I'll put a C there. Okay, and then we start off with our diagram looking like this for carbon. There's 2 dots together, 1 dot and 1 dot. Remember, through high orbital situation here, carbon can split its electrons out equally, so there's 4 equal places where those electrons can be, and then I can attach a bromine at each one of those locations. And again, notice how we're not showing electrons transferred over. We're showing them sharing at those positions where there's only 1 electron. And we'll just draw dots around it like this to complete up the dots that bromine would have. There are 7 dots for each of the bromines. I've used red to represent the electrons from the carbon and black, okay, to represent the electrons from bromine. Now, what does this compound actually look like? Well, we worked on building the molecule sets. So this would actually look like this. We have carbon right here. And then we have a bromine off down here, and a bromine off down here like this, and then a bromine off over here, and then we'll have one going upwards like this. This is kind of a 3-dimensional drawing of it, where we don't show all the other electrons. We just show like little sticks to represent the electron bonds and try to give some kind of geometrical shape, okay, to what the molecule looks like. In the days come, we'll be putting names to these shapes and geometries. And we'll also be putting names to the compounds, like this is carbon tetrabromide. Okay, but in the meantime, try some more of the compounds right now. Draw diagrams for the following covalent molecules. Pause the video, and then I want you to check your answers when you're done. These are the basic diagrams, and there's 6 basic types of diagrams that I want you to be familiar with. So go ahead and pause the video now. Okay, assuming that you've paused the video, let's take a look at the answers to these. Okay, BeI2, there's 2 dots for beryllium. Initially they're together, but we'll split them apart all the way across from each other. And we'll have 1 dot there, 1 dot there, and then iodine will latch on in those 2 places there. Iodine has 7 dots, plus 1 now is 8. 7 plus 1 is 8. We see that beryllium only has 2, so for covalent bonding, beryllium would not make a very happy compound, so it'll react. This, by the way, is an acid. Now what about H2SE? Well, Se has 6 dots, so we can line up 1 hydrogen there and then 1 hydrogen there and make 8 dots for the selenium and 2 dots for each hydrogen. Now they're pretty happy because hydrogen can only have 2 at most. That's one of those exceptions, and selenium now has 8. Now what about SiBr4? This is very similar to the carbon tetrabromide we did earlier. So silicon has 4 dots, and we'll split them apart so there's 1 at each location. And then we'll put bromines at each of the locations like that. So that's very similar. Okay, what about boron? Well, boron starts with 3 dots. There'll be 2 together and then 1 by itself. So 3 dots means we can do a triangular shape to it. So there we go. There's 1 dot there, 1 dot there, and 1 dot there. So that's what the dots for bromine would look like. And then we will have the remaining dots filled around chlorine. So chlorine has 7 dots, plus the 1 from bromine is 8. 7 dots plus 1 is 8. So each of the chlorine now has 8. Now if we look at boron, there's only 1, 2, 3, 4, 5, 6 around it. Therefore, boron is also an acid when it bonds by covalent bonds because it does not have its completely filled out energy level. Okay, what about nitrogen? Well, nitrogen each has 5 dots. And in order for it to share with another nitrogen, it must bring in 3 dots for each one and make 6 dots total in the middle, which is a triple bond. We might need more practice with double and triple bonds, and so don't worry too much about it right now, but we will work on that again. And last but not least, phosphorus starts off with 5 dots. Now here we've got 2 dots already together, 1, 1, 1. So there's only 3 places for chlorine to attach, one at this location, one at this location, and one there. Notice how phosphorus does have its 8 dots. It's got 2 extra dots on it, which makes it a base. When something is missing dots in the middle, doesn't have 8 total, it is called an acid. But when phosphorus gets its 8 dots, there are 2 electrons that aren't paired, or they are paired but just not bonded with somebody. And that means it's a base. So that's your difference between acids and bases. But at any rate, there's only 3 locations for chlorine to go on there, so therefore it's PCl3. All right, now what I want you to do is these molecules here, these 6 molecules that you've drawn out, I want you to match them with geometrical shapes that I have also drawn. So I want you to try. And here they are. So each of these circles represents atoms as if you were to make these molecule sets, okay, of each one of them. And I want you to match. Do you think this one's a beryllium atom? Is this one the silicon, from before? So those compounds from the previous slide, I want you now to match with these geometrical shapes. So go ahead and pause the video now and make your guesses. Okay, assuming that you pause the video, here's the answers to them. This one is beryllium to iodine. Here's our beryllium atom, and there's our 2 iodines. They line up in a straight line. This one's a bent shape, so this one's called linear. This one's bent. This is the H2Se, and the extra dots are located around here, so this is our selenium. These are our 2 hydrogens, and that makes a bent-shaped molecule. This one's the boron to chlorine 3 times, where we have a triangular shape. This one's actually called trigonal planar. Okay, so think flat triangle there. So there's one there, one there, and one there, and here's our boron in the middle. This one here is the PCl3, where we have 3 bonds angled downwards, and we have 2 extra dots on top here. This one's called trigonal pyramidal. Trigonal because there's 3, but it looks like a pyramid. This one's trigonal planar or trigonal flat. This one's trigonal pyramidal because the extra 2 dots are there. This one is SiBr4. Hopefully you recognize that from the other slide too. So we've got 1, 2, 3, 4 total bonds. This is a tetrahedral shaped molecule. And lastly, we have our triply bonded nitrogen N2 there. So hopefully that was a pretty easy guess for you to do. And that, of course, is also linear. Okay, so that'll do it for our review for ionic and covalence. I thought it was a good idea for us to take a look at those very carefully before moving on to other things.